reduction reaction, there must be corresponding oxidation reaction. So we cannot say oxidation reaction or reduction reaction. You can say oxidation half equation or reduction half equation. Now, there are so many ways by which this reaction can be defined. Carbon to zinc plus carbon 2 oxide. According to what is given in the definition of oxidation, if you look at from carbon to carbon 2 oxide, what happens? What happens when we have carbon to form oxygen? Oxygen is acid. And it's added. That is what? Oxidation. If you have from zinc oxide to zinc, what happens? Oxygen is removed. And that is what? Reduction. You can see this is an equation. And in this equation we have reduction, we have oxidation. So we cannot separate the two. And that's why we say the reaction is what? A complementary reaction. Are we together? That is one way to define oxidation reduction. Is the removal of hydrogen. Then what will be reduction? Reduction is the addition of what? Hydrogen. And of course, when there is removal of hydrogen, there must be corresponding. There was what? Corresponding addition of nitrogen gas to give us hydrogen chloride plus sulfur. This is an equation. If you move from chlorine to hydrogen chloride, what happens here? There is what? Addition of hydrogen, because hydrogen was added to chlorine, that is why you have what? Hydrogen chloride. And what process involves addition of hydrogen? So that means we have reduction here. And from hydrogen sulfide to sulfur, what happens? There is what? Removal of hydrogen. So I say this is what? Oxidation. It also means in this reaction we have reduction, we have oxidation. And the first element are okay, those elements that have tendency to lose electron are referred to as electropositive elements. So now let us use electropositive element or electronegative to define oxidation reduction. So we can say 3 now is the addition of electronegative element or removal of electropositive element. Oxidation is the addition of electronegative element or removal of electropositive element. In that case, we can now define reduction. Reduction now is the removal of electronegative element or addition of electropositive elements. So when you are giving a definition, you have to be very careful when you are giving a definition, because if you miss one, you are likely to miss the other. So that you have to be very careful so that you don't give wrong definition. So we say oxidation is the addition of electronegative elements or removal of electropositive elements. Whereas reduction is the removal of electronegative elements or addition of electropositive elements. Now let's look at this equation. Then we have iron 2 chloride reacts with chlorine to give iron 3 chloride. This is an equation. Now, which of these elements here is electropositive? Which one is electronegative? Electropositive, and which one is electronegative? Yes. Okay. Iron 2 is electropositive and chlorine is electronegative. Now let us look at how we can. What process occurs here when we move from iron 3 chloride to iron 2 chloride? What happens there when you move from iron 3 to iron 2? Removal of electronegative elements. And what is removal of electronegative elements? We have now reduction. Are we together? So you get the definition. You can define the oxidation reduction in terms of in so many ways. You don't know how to define in terms of electronegative elements, and you don't know how to define in terms of electron transfer, you may not get it right. So you should be able to define the reduction, oxidation in each of the terms we have got. That is one way. We can also define oxidation reduction in terms of oxidation number. In terms of what? Oxidation number, we are going to define it later. Oxidation is the increase in oxidation number. The reduction is the decrease in oxidation number. Look at this equation. What happens to sulfur from left to the right? There is what? We are not talking. What is oxidation number of sulfur here? -2. What is the oxidation number here? 0. You know that 0 is greater than -1. That means there is what? Increase in oxidation. And what process is that? What process is that? Oxidation. So this is oxidation. Now I will not. This is that what? Oxidation. Half equation. Because it is standing alone. This is what? Oxidation half equation. It is oxidation because we know there is increase in oxidation number from 2 to 0. Is that again? Now let us look at this one. So this is another example. We have Fe3+ going to Fe2+. What happens to the oxidation number here? It is what? It decreases. Because the oxidation number of iron here is what? +3. Here it is what? That means there is what? Decrease in oxidation number. What process is decrease in oxidation number. That is what reduction. So it means for this one, reduction have equation. This is what? How many ways have we defined redox reaction now? Oxidation is the addition of oxygen. Reduction is the removal of. Reduction is the addition of or removal of positive elements. While reduction is the removal of electronegative elements, or you can say oxidation is increase in oxidation number, while reduction is. Now we can now define oxidation in terms of electron transfer. So let us define it in terms of electron transfer. So we can say oxidation is the loss of electron or electrons. Then reduction is the gain of electron or electrons. So we reverse to the reaction as complementary reaction. Because for there to be oxidation, there must be corresponding reduction. And from all the definitions of being here, you will say that it shows that the reaction cannot be separated from one another. Now, if there is loss of electron or there is gain of electron, if there is addition of hydrogen or there is removal of hydrogen, a substance or an agent must lose the electron or accept the electron. These agents are either oxidizing agent or reducing agent. So let us look at reducing agent and oxidizing agent. Reducing agent and oxidizing agent. So reducing agent and oxidizing agent that loses electron is referred to as reducing agent. A substance that loses electron are referred to as, you can say, reducing agent. Are substances that lose electron or electrons. So other words, you can say reducing agents are electron donors. Metals are reducing agents. Metals are what? Because when we get metal are those elements whose atoms are ionized by loss of electrons. So they are referred to as what? Reducing agents. That means we are asked to give example of reducing agent. You can mention metal. Sodium, potassium, what have you. Is sodium not ionized by loss of electron? With potassium not ionized by loss of electron. So they are what? They are what? So examples are metals. Examples are metals. Give me an example. They are reducing agents. We have some gases like sulfur oxide is a reducing agent. We have hydrogen sulfide, reducing agent. That tells you that some metals are reducing agents. Some gases, not all gases, some gases are what? Reducing agents. We also have some compounds that are reducing agents. Can you give an example of a compound that are reducing agents. Fe, iron 2 chloride. So we have compound like iron 2 chloride, LiAlH4. And what is the name? Don't worry. Oxidation agents are substances that gain electrons or electrons. So in other words, you can say oxidation agents are electron acceptors. At donors, there must be acceptors. If you are given equation, if there is an oxidizing agent, there must be what? Reducing agent. Because if you just have a reducing agent without oxidizing agent, if electron is lost, what will accept the electron? That's it. Prove that you cannot separate oxidation reaction from reduction. Now, let us have an example of oxidizing agent. Non-metals are elements whose atoms are ionized by what? That means non-metals will become ion when they gain electrons. So, are we together? Which other compounds or other substances are oxidizing agents apart from the non-metal? KMnO4. So we have KMnO4 acidified. KMnO4 is an oxidizing agent. Yes, acidified. K2Cr2O7 is also a strong oxidizing agent. Are we together? You can use iron 2 chloride. Iron 2 chloride is green. What you do is to get the test tube, you have the iron 2 chloride there, it's green. Then what you suspect to be an oxidizing agent, you add this to this. If the color change to reddish brown or yellow, you can see what you have added is an oxidizing agent. So no question. So God bless you as you attend today's lesson. See you next week.